OpenClaw, OpenClaw, OpenClaw. If OpenClaw fails, it will not be just another AI side project that fizzled out. It will be the moment we realize that handing a self-hosted AI agent root access to our entire digital life might have been a historic mistake. For years, we kept AI in a box. You visit a website, type a prompt, get text back, done. Clean, contained. It cannot touch your files. It cannot see your inbox. It cannot log into your servers. But an open source tool built by one developer shattered that model. It quietly wired itself into personal emails, private servers, crypto wallets, Discord groups. It behaved less like a chatbot and more like a tireless digital employee. And if it goes wrong, you do not just lose a fun experiment. You risk your passwords, your savings, your company code, your reputation. Because of how it operates, you might not even realize what happened until you wake up and everything is gone. Today, we are breaking down the wild rise of OpenClaw, formerly known as Claude, how a solo side project exploded fast enough to rattle major tech companies, how a chaotic rebrand sparked a $16 million crypto disaster, and how the very architecture that made it powerful opened the door to a malware ecosystem. This is the God Mode AI nightmare. OpenClaw began as a weekend hack in late 2025. Its creator, Austrian developer Peter Steinberger, wanted something better than a browser tab for his language models. So he connected an AI to Telegram, gave it access to his shell, let it browse the web, and read messages directly on his machine. In January 2026, he pushed thousands of commits. He vibe coded at a relentless pace, often running multiple AI coding agents in parallel. He described it as one guy at home building for fun. Within 2 months, the project crossed 100,000 GitHub stars. That milestone usually requires funding and teams. OpenClaw did it in weeks. The repository became the product. The README became the landing page. The stars became instant social proof. Why did it spread so fast? Because philosophically, it rejected how big tech was building AI agents. Tools like Claude Code live in a sandbox. You open a session, assign a task, get an answer, close the terminal. It disappears. OpenClaw flipped that model. It was a horizontal, local first runtime employee. It ran persistently on your hardware, MacBook, Raspberry Pi, cloud server. It did not wait for prompts. You assigned long-running jobs. It had memory. You could tell it to triage your inbox at midnight, monitor a Discord channel and summarize it every Friday, compile reports while you sleep. Through extension modules spanning apps, file systems, and browsers, it had near total context. It could see what you see. It knew what you knew once logged in. But to act like an employee, it needed your keys, API tokens, read and write permissions, shell access, execution rights. That design choice set the stage for disaster. Why would anyone accept that risk? Because the upside felt magical. Imagine dinner with family. Your phone buzzes. OpenClaw messages you on WhatsApp. Your biggest client's AWS server just crashed. Normally, your night is over. You grab a hotspot and dig through logs. With OpenClaw, you reply, "Fix it." The agent reads logs, identifies the error, uses SSH keys to access your instance, restarts the failing Docker container, verifies uptime, then texts back. All good. Enjoy dinner. To power users, it felt like a senior engineer and executive assistant combined, working 24/7. That magic required deep trust. You were giving an open source runtime the keys to everything. Once attackers understood that, they did not need to hack you. They needed to hack the agent working for you. During its viral rise, the project was called Claude. That name triggered trademark concerns from Anthropic. It briefly rebranded to Moltbots. Eventually, it settled on OpenClaw. Sounds administrative? It was not. During the confusion, scammers launched a fake Clawud token, claiming the rename signaled an official AI coin. Bot networks amplified the narrative. Hype did the rest. The token peaked near $16 million before collapsing to zero. Peter publicly begged people not to buy it. He had nothing to do with it. But millions vanished. That was only the warm-up. The real threat lived inside ClawHub, the official skills marketplace. Because OpenClaw was modular, developers could publish skills that extended its powers. calendar management, social posting, DevOps helpers. On paper, it was brilliant. In practice, it became a supply chain nightmare. One top ranked skill called What Would Elon Do promised to read your timeline and generate bold business ideas. It looked legitimate. Thousands of downloads, clean documentation. Security researchers later found 9 vulnerabilities, including critical prompt injections hidden inside its markdown file. The skill quietly exfiltrated data to attacker controlled endpoints. It embedded instructions that coerced the AI to bypass internal safeguards. In some cases, Base 64 encoded commands decoded into curl fetches that pulled second stage payloads, triggering atomic macOS stealer. Traditional antivirus did not catch it. The malicious logic was written as plain English instructions for the AI agent to execute. You had already granted shell access. No pop-up required. Picture 2 a.m. The agent wakes. It opens a hidden shell, fetches a payload, scans environment files for API keys, extracts browser cookies, copies crypto seed phrases, sends everything out. At 8 a.m., you ask it to draft a tweet. It responds cheerfully. Meanwhile, your accounts are compromised. Researchers auditing ClawHub found hundreds of malicious skills, roughly 12% in one sample. Crypto bots, SEO tools, DevOps scripts, inflated downloads, fake reviews, coordinated abuse. The most downloaded skill at one point functioned as a malware delivery system. Security experts have warned about this. When an AI agent has persistent memory plus shell and API access, prompt injection becomes remote code execution in disguise. To their credit, the OpenClaw community reacted fast. Virus total integrations, AI-based scanning, stricter publishing requirements, permission sandboxing, heavy updates. But the lesson stands. Third-party AI skills are untrusted code. Until isolation and privilege separation are airtight, installing them is a gamble. OpenClaw showed us a glimpse of the future, personal AI agents doing meaningful work across apps, a solo developer forcing giants to pay attention. Peter is now joining OpenAI to work on agents while keeping OpenClaw open source. It also showed how thin the line is between assistant and autonomous malware installer. If you experiment with OpenClaw or similar frameworks, follow 3 rules. Update immediately. Run the latest version. Treat every community skill as untrusted. Inspect it. Read the markdown. Question excessive permissions. Lock down access. Avoid blanket root permissions. Use separate accounts and browser profiles. Constrain the blast radius. Is OpenClaw the blueprint for managing fleets of AI employees? Or the warning shot we needed before this tech scales further? If you want a follow-up showing a secure sandbox setup for testing it safely, let me know. And subscribe for more deep dives into real-world AI tools and the risks hiding beneath the hype.